So this is the explanation for the bipolar RC line coding and the alternate mark inversion. And these two signals or line codings are very similar. The only difference is that the AMI or the alternate mark inversion has a complete pulse, while the bipolar RC has half the pulse. And the main characteristic of both of them is that on the first one, both starts at high state, but on the next one, in the input, the signal goes to a -1, or in here, or lower state in here, and in the 0 it remains in a neutral state. And here in both, just the only difference is the pulse duration, that this one has a complete pulse in here, and this one has half the pulse at each one. So for both of them, it's more or less the same configuration. We got a JK flip-flop. In here, these equations that are described in the document are for changing states, so that it changes state from this one that is the x1 to this one that is x3. I put some probes in here to check in which state it was. Also, well, this one, what it does basically is just change states from this one to this one. Next, then this a signal from this flip-flop was connected to a relay. This relay is going to choose which signal is going to send to our output. In here, we are going to check our output. So basically it's the same signal, just that one is going to be in positive and one is not going to be negative, for creating this change from positive to negative. So this one is going to change, is going to make this one change from positive and then go to negative. And we had another relay connected for the neutral state, that is going to be the 0 state, when this our main input is on and off. So if it's on in here, this one is going to just get a 0 in here, but if it's off, it's going to choose between these two, alternating between one another and alternating between this one and this one. And this is more or less how it does works. So we have we start with a 0 or in here, or we see that our clock, it's normal, but on our output is just comes to 0 because we haven't activated in here. But if we activate this one, we see that in here, more or less, it is going to alternate the signals between positive to negative at the same rate as this clock. I'm going to just change this one a little bit so that this is a more clear, the change. So it's basically that it changes from 1 to 0, and if we got 0 in the input, it's just going to remain 0 the rest of the output. So this is basically it. This is the AMI linear code, and the bipolar linear code is exactly the same thing, just that in here our clock signals are going to be just the half, in order for creating this, what I say that it was half the pulse. So that's the only difference between these two. And in here we can also check this, that in here we have a 0. When we have this 0 state, we have the first state, it's going to be half the pulse of which I'm going to stop in here the simulation. So at each pulse of the main clock, here we have the half of the pulse on one in positive, one in negative, one in positive, one in negative, and so on. So if we also change this one to 0, it's going to the states go to 0. And that's basically how the bipolar RC and the AMI line coding works.